We need to obtain the value of derivative of y with respect to x whenever y is given by cosine of x raised to the power of x. Let's begin. So here we have y given by cosine of x raised to the power of x. Now what we'll do, we'll use a definition of logarithm that says whenever we have e raised to the power of natural log of a, this becomes equals to a. So that means if we consider a to be equals to x raised to the power of x, then we can rewrite x raised to the power of x as e raised to the power of log of x raised to the power of x. Now we can also make use of the property that we know whenever we have log of a raised to the power of b, so that's equivalent to b times log of a. So that means log of x raised to the power of x can be rewritten as e raised to the power of x times log of x. So let's use this. Now that means we will now have y equals to cosine of e raised to the power of x log x. Fine. Now what we'll do, we'll take the derivative on both sides with respect to x, such that we have derivative of y with respect to x equals to derivative with respect to x of cosine of e raised to the power of x log x. Fine. Derivative of the cosine function, that's the sine, negative sign function, so we have negative sign. So here we have e raised to the power of x log of x. Now since this is not x but e raised to the power of x log x, so what we'll have to do, we'll have to take the derivative with respect to x of e raised to the power of x log x and multiply it to negative sign e raised to the power of x log x as a consequence of the chain rule. Fine. So let's find out the value. So we have negative sign of e raised to the power of x log of x. Now we know the derivative of the exponential function, that is the function itself. That means whenever we have derivative with respect to x of e raised to the power of x, so this gives back the exponential function. So that means we have derivative with respect to x of the exponential function e raised to the power of x log x, so we'll get e raised to the power of x log x. But since we have x log x instead of x, so we'll have to again use the chain rule and multiply it to derivative with respect to x of x log x. Fine. So let's find out the value. So we have derivative of y with respect to x, thus that's equals to negative sign of e raised to the power of x log x multiplied to e raised to the power of x log x multiplied to, so here we can use the product rule. So we have x times derivative with respect to x of log x plus log x multiplied to derivative of x with respect to x. Fine. So that means we have derivative of y with respect to x equals to negative sign, so e raised to the power of x log x, so that can be replaced with x raised to the power of x minus here e raised to the power of x log x, so that will be also replaced with x log x. Now here we have x times derivative of the logarithmic function, which we know that derivative with respect to x of log of x, so this value is 1 over x. So that means we have x divided by x plus log of x multiplied to derivative of x with respect to x, so that's 1. Fine. So this now finally gives us the value of derivative dy over dx. So derivative of y with respect to x, that will be equals to negative x raised to the power of x times sine of x raised to the power of x, whole thing multiplied to, so x and x cancels out, this leaves us with 1 plus log of x.